Good evening, everyone. So, if you can hear me, then we can get going. Don't stop the music. That's the first thing Zero writes on the chat. Yeah, and I agree. Actually, I really like that piece. It's absolutely amazing. So, it's a little bit sad I had to cut it early, but it seems I mistimed it a little bit. It should have been turned on a little bit earlier by like 10 seconds, maybe. So, hey everyone, good evening, good morning, depending on which time zone you are in. I would like to welcome you to Ginbale's Live, and today we'll be handling, hacking Google, or rather the bonus challenge of episode 5, which is technically, I guess, the last challenge in the whole event. So, before we get to it, I guess like some more people are usually coming in the first couple of minutes, so I would like to use this time to thank my moderators today. That would be Foxtrot Charlie and Masakra, and also I know Hlinur is helping a little bit with the actual task, so that's absolutely amazing. Thanks folks for being here. And obviously I would like to thank everyone who came, because you will be needed today, while usually this is more like a lecture, I guess, where I show you a task and I try to solve it, or rather I solve it. Especially that usually I show tasks which I've made, right? So today it's going to be a little bit different, because the challenge today will require your help as well. We will have to raid another YouTube live stream, and we'll have to vote there to get my solution, the solution which I will create during this live stream, into the how to call it? Let's call it firmware, maybe, into the firmware which is running on that live stream, and that way we will be able to somehow maybe get the flag, but that's still a long way basically, and I'm kind of getting ahead of myself. So I think we can, start by talking about what is Hacking Google. And Hacking Google is this absolutely amazing docuseries with multiple episodes. I believe there are like 6 of them, counting from 0, properly, like, hacker-like, right? Or programmer-like, whatever you want to call it. If you Google for Hacking Google, then you will find it. You can also go to Hacking Google, but that's written actually with an 4 instead of A and 1 instead of I. And there are 6 episodes, and I totally recommend watching them. They are absolutely amazing, and you can learn quite a lot about the folks who are responsible for securing Google, or some of the folks rather, since Google has a pretty large security teams, but some of the folks are there, including, for example, my manager. So maybe you can spot my manager. Hi, Eduardo. Yes, I want to raise. Perfect. Let's get going with the site, because docuseries is one thing, but apart from the docuseries, the other thing which was actually released was a set of, or they were actually released even before the docuseries, was a series of challenges, of let's say community hacking challenges. This wasn't a CTF, this wasn't an event where people played in teams against each other. Rather, this was a little bit more like Beginner's Quest, which we do from time to time, or we try to do every year. And each episode had a couple of challenges related. If people unlocked them, then the next episode got unlocked. If people unlocked all of them, then they also get a bonus challenge in each case. So we are ready. Let's go here. As you can see, the interface is pretty awesome actually. The bonus challenge it has status incomplete. I'm not sure why. Actually, it was solved already by 2 groups of people. Let's make it a little bit bigger if I can. Let's see if I can make it a little bit bigger. Here we go. It scales nicely. Now it's a little bit more like in the olden days when everything was big. So if we go to the Hall of Fame, which we absolutely should do, we are going to look at the names of the people who actually solved the bonus challenge. These are, on the left, you can see people who solved other challenges, or rather all of the main challenges, but we are interested here. These are the 10 folks who solved the actual challenge I'm going to show you today. Now, from what I know, these were actually 2 different groups of people, as you can see by the dates as well. So Shimex73 led one group, and I know he actually created even, because we will be coding in BASIC, and he actually created a BASIC compiler which compiled BASIC into BASIC, but it was like basic with actual features to really simple basic, which we'll be coding in actually today. So they solved it pretty fast. Actually, I think like 2 days after the challenge was released. And these are the 3 folks. And then, as you can see, there's another group which solved it 3 days ago. That was just before the Hall of Fame actually was frozen, because currently it's frozen. That's why I'm showing this. And yeah, so also congratulations to the other group. So congrats, folks. Really well done. As you might know by now, I am the author of this challenge, actually. So while saying that I will try to solve it, I will actually solve it because I know how to solve it. Unless I fail hard and then I don't solve it, but we'll at least have a couple of laughs, which is also good, I think. So I'm, as an author, I'm really happy that somebody actually solved it. Congratulations. And you will learn, folks, which are here, what they had to deal with, basically, during the next, I guess, 1 or 2 hours, depending on how it goes. I'm guessing it's going to go more like 2 hours. My guess is that the first half an hour, or maybe let's say 20 minutes, we'll be digging through the task. There is quite a lot of information about the task available. And then we'll actually start to go to the other channel, to the challenge channel, and start implementing the solution. Okay, so where do we start? We click here again. No, we don't have to click here. We click Open Challenge, Bonus Challenge. Yeah, looks like a meeting just popped up on your calendar, and we have a link. So if we go to this link, and I can give you a link on the chat as well. By the way, folks, we'll have time for questions during the voting, because we'll have to input a lot of lines, and each line takes about a minute to input, so we'll have time for questions, no worries. Okay, so this is the WebDriver Brain. The name might sound familiar, right? If we go here, this is actually a live stream which is running from October 11th. It's actually running even longer than that, but I did have to reset it. Let's make it a little bit bigger. What we can see here is, we can see on the right side, this is a CCTV camera, perhaps, or I guess that's like, yeah, like CCTV camera, right? That's like a closed circuit TV, which is monitoring a conference room at Google somewhere. I actually don't know where. Perhaps it's New York, but I might be mistaken. If anyone knows, do let me know. And yeah, like we can see a desk, a couple of chairs. These are microphones, by the way, the round black things. This is an interface to control the whole meeting equipment, I guess. And there's a camera, there's some speakers, there's a TV. That's all we see now. On the left side, we have 2 interesting things. We have 2 interesting interfaces. The first one is, yeah, we don't know. It says ready. It's ready for something. We don't know what it is ready for yet. And the other one says phase failed. No commands were proposed. More info. At least 1 command needs to be proposed. If there are more than 4 commands proposed, 4 will be chosen at random for the next phase. Length limit of a command is 71 characters, and it's a voting bot. So, if you ever played, or rather if you know what's Twitch plays Pokemon or Twitch installs Gentoo or whatnot, then this is something similar. This is actually like YouTube solves a CTF challenge, apparently. And as you saw before, at least 10 votes were required, so we'll need at least 10 people to be able to solve it. And there are 2 phases. One phase is where people enter commands, voters propose commands, and yeah, and if a command is proposed, then we'll be able to vote on the command. There might be several commands, up to 4 commands, as you can see. And at least 10 people are required, but actually the more the better, because the number of votes required differs. But okay, what is this console? What will be voting for? Let's look again at the challenge description and let's see. Now, if we click Open Challenge, what does happen? If we click Open Challenge, we go to a PDF, which is called Controller Datasheet. So it's a datasheet, and what can we read here? Controller datasheet. Thank you for purchasing our versatile 8051. So we already know the architecture. It's 8051. 8051 is a really simple 8-bit microcontroller or processor, if you will. it's pretty old, but you can still find them. You can find them in like small network switches, even managed network switches in, like for example, LCD controllers. You know, the main board of your LCD monitor, which you might have, it actually also has a CPU on it. And the CPU, it drives the on-screen display, the menu basically, which you see. And yeah, so it can be 8051. So it's a pretty known architecture, nothing weird there. Let me make it a little bit bigger even. Okay, and it has a built-in best device bus, whatever is that, but it has a TM. This datasheet contains some information about the controller and its UBasic programming interface. So yeah, if you were an owner of an 8-bit computer like Atari or Commodore or Spectrum or something like that, or even Amiga. Amiga is like, it's not 8-bit obviously, but it had BASIC, like there was Amiga BASIC. So if you're an owner of such a computer, you know that you could program there in a programming language called BASIC, which is a language, if I remember correctly, and I might be mistaken here, created in like 1965 or something. It's like super old as far as programming languages go, right? Like, yeah, I guess like Rust isn't that old. Anyway, so it's, as the name implies, super simple. It's really basic. And funnily, it's not a compiled language, it's an interpreted language. So you actually would like type in the program and then it would get interpreted. Each line, when executed, would get parsed and executed based on whatever the interpreter figured out about that line. So it's not compiled to assembly, it's rather interpreted, which meant also it's super slow. And hopefully that doesn't play a role, but maybe it does, we'll see. Now, one thing which we will see is that, well, which is kind of written already here, is a basic, UBasic, or rather micro-basic, I believe, programming interface. So back in the olden days, what you actually had, you didn't have, well, editors like you have now. Like, you know, you open Vim or you open Sublime or you open, I don't know, Visual Studio Code. And you just like browse around the code with your arrow keys or your mouse, right? But that wasn't the case. Back in the days, the editors were way simpler. What you had to do is you had to actually type the line number which you want to change, for example, 10 or 20, and then the content of that line which you want to put there. And by the way, people didn't use lines 1, 2, 3, 4, rather we use like 10, 20, 30, 40. Because, well, if you forgot a line, well, how do you insert a line between them? You cannot really shift them. So how do you do that? Well, you could, if you, use the spacing of 10, you could then use, for example, 15. So 10, then 10, 20, and then you forgot something, so you do line number 15. That was a little bit, well, not as good as, programming is now, but this is something we can probably expect here. If we would go, for example, to Gainbale CPC 464, which is another 8-bit computer. Yeah, exactly this image. Can we zoom it? Please, can we zoom it? Okay, it's small, but you can kind of see on the left side here that there were lines, right? So the ready we already saw ready today, right? So if you typed list, then you would get the whole program, and then if you wanted to change a line, you would type, like, for example, 10, and you would retype the line what you want to change it to. There were like some computers had like some simple copy paste or whatnot, but at the end of the day, it was a rather not an easy job. Okay, I see a lot of folks are already there. What you can try to do, you can try CMD list. Sorry, let me pop out the chat and move it here maybe. Okay, perfect. And we'll get to this point in a second. Okay, so what else do we know about this controller, which is supposedly, I guess, in the room, right? Like we see the room here. I'm guessing the controller is there and it's connected to something. Otherwise, why would we even have access to it? So, okay, we know the CPU, external RAM 64 kilobytes. That might sound not a lot, but it's pretty typical. That's okay. Then, okay, then There's a question that I know these times. Yeah, I've learned programming in these times, where you had to use the line editor. It wasn't that bad, actually. I liked it. But I liked moving away from it as well, actually. Okay. Anyway, the UBasic which is used, the microbasic, is from Adam. From Adam Dunkels. And this is a really small basic implementation created by Adam for whatever purposes. It's on a BSD license, so it's open source. And we might actually have to download it and like test it, because we don't really have a simple way to interact with the device, so it's best that we just go with downloading this and testing applications first on it before we start doing something on the with the challenge. Cool. Okay, let me move this here, perhaps. Yeah. So let's keep reading. Then internal devices versus serial device, which I guess is like input-output. Best device, bus, router, whatever that is. 8-bit register, write only, and 8-bit. So 8-bit register, that's just like a chip which can hold 8-bit value, and you can like query the chip for that value. Yeah. Then there's an 8-bit I/O extender. So an I/O extender is also a chip which is like basically if you have not a lot of I/Os, not a lot of pins which you can connect to other devices, for example for communication or like lighting an LED or like controlling a step motor or whatnot, you can get basically another chip which is an extender, and you then communicate over some bus. Usually that's I2C, but it can be anything else like SPI or whatnot. And you communicate with it and you say, tell it, hey, okay, on this pin set a 1, on this pin set a 0. So it has 8-bit port, which means it has 8 pins. Like it has, you know, the chip has 8 legs, which are can be connected to some other devices. And then we have this best device bus devices, and it's the 8-bit register, perhaps it's the same one, an 8-bit adder, which I guess is like, you know, used to add a number to another number, I'm guessing. It's called an adder. So I guess the result is also 8-bit. I wonder there might be a carry port, we don't know. Then there's the extender. It might also be the same extender. So what we can see here is that it's write only if we access it as an internal device, but it suddenly like it doesn't have this remark at all when we access it over the best device bus. And then there is the FlagROM, and this is what we want to get. We want to get the FlagROM. And why? Because the FlagROM contains the flag. And what's the flag? The flag is a secret, and the secret used to solve a challenge. In case of normal CTFs, it's just like a string, which is prefixed by like CTF, and then there are like curly braces, and then there's like some funny phrase or a hash or whatnot, like, you know, a random string basically, a random unique one, and then a closed curly brace. In case of this event, because it's not a CTF, the flag is actually a link. And we know that. We know that as players because we solved other challenges, and each other challenge, the flag was a link, so it's also a link here. Cool. Okay, so yeah, this is the basic, and this is apparently we can analyze how this window here, this window on the left here, works. So we have what? If somebody put in 10 print hello world, then 20 print hiver, and then issued the command run, it actually ran like hello world hiver, and then somebody issued a command del20, and then listed the basic program. List and run are like super typical basic commands, like every basic had them, or rather every basic with line editors had them. Fun fact, Microsoft created basic interpreters, I think at the beginning of when the company was founded. Then they moved into operating systems, but they started with basic interpreters. Anyway, so yeah, then list, and as we can see, like line number 20 was actually removed. And then run obviously didn't run line number 20 because the line number 20 was already removed, so it just ran hello world. Okay, so and they say our controller comes with a built-in lowercase. In Atari, for example, Atari X100 XL, which I played with, or rather learned programming on, basic was uppercase. You had to use like uppercase letters only. Okay, otherwise, yeah, this is a basic editor and an execution environment. Fair. And we have line editor's command. So we have line and text, which is like, for example, 10 print whatever. Yeah. And this is like place text as at a given line, and this is an example. Perfect. Delete line, pretty obvious. Then we have list, pretty obvious. We can list just one line. We can list from a given line onwards. For example, list 110 onward, but dash there means onward. A range of numbers, rather range of lines. Then we can run the program from the first line, or we can run a program from a given line which we choose. Please note, all variables must have single letter names. This is, atypical right now, but for example, on Commodore 64, you could have variable names which are long, but only the first two letters counted of a variable name. So if you have a variable name called ASDF, then only AS were used to name that variable, and everything else was basically like a comment and ignored, which is pretty funny. Here, single letters. All variables and constants are 8-bit unsigned integers. Makes sense? And poke and peek. Poke and peek functions are used to put things in RAM and get things from RAM. Or communicate through MMIO, which is like memory mapped IO, which means communicate with the devices. I'm guessing like devices listed here. This is pretty typical in like 8-bit computers. This is nothing related to this challenge. If you knew BASIC, you would know that. If you don't know BASIC, you would have to learn that. So these two functions are mapped to the first 256 bytes of XRAM for convenient use of MMIO. So this already tells us that the MMIO, which is like communication with other devices, is actually mapped in the lower part of XRAM. XRAM being the external RAM, being the 64 kilobytes of memory in this chip. 8051 actually has like 3 different RAMs. It has, or rather 3 different memory ranges. It has XRAM, it has like internal RAM, and it has, I don't remember, well, the code has anyway a separate region. I don't remember whether SPF, which is Special Function Registers, is actually part of IRAM, which is the internal RAM. Never mind, doesn't matter, we only have access anyway to XRAM, to the external RAM, and only to 256 bytes of the 64 kilobytes which exist. So not a lot of memory for us to use actually, but this doesn't include any variables. We can have variables, well, I guess 1 letter, so we can have 26 variables, which is good, which is enough. For details, go to this link, and yeah, we can analyze the code, we can download it, we can play with it. Perfect. Okay, so then we have devices. I see you're trying to vote already. As you can see, it requires a lot of people. It requires at least 10 people, and it might require even more if we are successful with a vote. So, devices. What are the devices in this controller? The microbasic interface allows access to some devices either directly using the MMIO interface mapped at the first, so using peek or poke function we can directly access some devices, or indirectly using the best device bus router device. So there is some router device which I guess is going to be mapped through the like poke and peek interface, and we'll have to deal with that. If you know embedded programming, if you played with Arduino, you are used to this kind of stuff. If you haven't, just note that if you access some registers in memory, you aren't really writing to memory, you are just like sending data to a device. And there are registers, they are called registers, like memory addresses basically, which are used to control that device. So whatever you put there, you can configure it, and you can, like, for example, if you have a graphic card, there might be registers in memory where you would set the resolution. So you put in one register one, like, the width, and the other the height, and then there would be another register to basically apply the configuration, and that's basically how you actually low-level program devices or configure devices. And this is true also for modern devices, not only for these like old or embedded devices. Cool. So this is the best device router. I'm going to skip it for now. What we are really interested in is the 8-bit I/O extender. Because, well, if we have a device, right, and if it's connected to anything in the room, like let's keep in mind that we have this camera view. So if it's connected to anything in the room, it's going to be connected through this I/O extender. Because that's why you have I/O ports, to connect it to other devices. I/O input-output, that's how it works. That's how it works on Arduino, that's how it will work in this challenge. Okay, so what do we do? What do we have here? We have this XRAM MMIO, which is the address in memory where this port is present, and it's on address 23. It's only 1 byte, like each address in memory is 1 byte, so 8 bits, 1 byte, perfect. We can just write into this address and see what's going to happen. The 8-bit port I/O extender allows the user to interact with any external devices. Each bit of the 8-bit state register corresponds to one external device, if connected. Not all pins have to be connected, obviously. For example, this can be used for simple switching on and off of external devices. Okay, what could we switch on and off here? Perhaps the TV, maybe something else. This I/O port is available both directly via MMIO on address 23, write-only behavior when reading is undefined, which means we might get something, we might get nothing, and via the best device bus, and then it's read and write on address 15. So it's a different address, obviously, because it's like the best device bus has its own addresses. If you are familiar with I2C, then it's probably a similar thing, or any other buses. Only register 0 is available, so it's like might be super similar to I2C. Actually, there might be, we will have to read the documentation of this, but it seems there will be addresses of devices connected to the bus, and each device might have multiple registers which you can access, which you can read or write to. So the first thing we are going to do actually is we are going to figure out how to use peek and poke, and we are going to write something to this port. I'm going to write, okay, so let me grab some notes. Okay, so here are the notes. We have what? Address 23. And then we have, yeah, and then what do we write there? We want to write there to 23. Because it's an 8-bit I/O port, I would write two values. Let's start with writing a value 255, which is equivalent of OXFF, which is equivalent of all bits being set. And then we are going to write 0 to it, because, well, 0 is 0, so, you know, every bit is off. So if there's something connected to it, it will either turn off or turn off or turn on during one of these actions. Now, how do we use poke? Usually in poke we use something like this, poke, and then the address, and then the value. It might be the same in this basic. To check that, we can actually download this. So let me open a console maybe. Here, let's make it a little bit bigger. And we can do git clone, and let's download this basic. Okay, let's make it. Okay, and well, there are like a couple of ways to go about it. We can, for example, use this ubasic.c and change this to whatever we want. So, for example, we can put, let's put like 10 poke 23255 here. Let's compile it and let's see if we can run it. We don't need this one. Maybe, you know what, we are actually going to do 20 print 1 here, just so we know that it actually worked. So let's compile it again, test this up to date. How do we compile GCC ubasic? And then we have to, I guess, use the ubasic.c and tokenizer.c. Okay. Segmentation fault, core dumped, perfect. Why? Okay. GGDB, we can do GDB out and see. Run. Okay, where? Okay, so it goes into poke statement, and then it goes into, yeah, it crashes. Why does it crash? Where's the poke statement? It's in ubasic.c, so let's open that file and let's take a quick look. poke statement, here we go, and it calls expression, and then it calls the poke function, but what's the poke function? So a poke function seems to be some a pointer, and I guess it's pointing to null right now, but which isn't great. So what's the type, by the way? The type is called this. Where is that type? Let's grep for it. It's defined here, type def. Let's make the console a little bit bigger so everyone can see. It's a variable type and variable type. Variable type, we know it's unsigned int for us. For it might be a little bit different. So let's make a function called void myPoke, and then give it two variables. That's going to be the address and that's going to be the value, I'm guessing, because that's how poke works. And I'm going to create my own function which does which tells us what are we poking at. AV. Okay, here we go, and here we are actually going to set this function. So let's recompile it, let's run it, and yeah, it worked. So yeah, we just here it's actually using the variable type. What's the variable type? We can do grep, but only in H files, and we see variable type here defined as a character, but we know from the documentation, right, that it's every where was that? Here. All variables are constant 8-bit unsigned integer. Now a char or a char, however you want to say it, it's well, that's, you know, that's signed on Linux, so we have to change it to unsigned char. Okay, let's do this again and let's run it. Okay, now it's 255, so everything works. I guess we can input this program. So how are we going to do it? We are going to do it like this. And this is the program we are going to input. There are two phases of this. First, there's the command proposing, and if everyone could go to this is the moment we start raiding. If everyone could go to this live stream, and I'm going to propose a command, which I'm going to type !CMD and then the command name. And then I would ask you, after the command is shown as the proposal, I would ask you to actually vote for it. That would be, but you have to time it right. You have to wait until the proper phase is here. So voters propose command not yet. And yeah, because no commands came, then we have a cooldown. When the commands will come, it will actually show you the list of the commands, and it will tell you on top, vote now. This is where you should type !vote, and then the number of command. Ideally, vote on my command. If there are any other ones, then yeah. Cool. So, am I at the newest part of the stream? Yes, there is no delay. Where is my editor? My editor is here. I'm going to do this. We still have a cooldown. Now, I'm not... oh. You know what? I do need to open this in another place as well. Wait, I need to put this out. Okay, there we go. Okay, so let me maybe change the resolution. Okay, so actually Masakra already put in the command which I want, so that's perfect, thank you. Let's just wait a moment, and now you can vote. Remember, they're like, yeah, now you can vote a number. Please vote on either 1 or 2. Either will work. Okay, 13 votes, that will be already enough to go through it. Thank you, everyone. Okay, we have a winner, so we already inputted this command. Now what we need, the next one, is we need to do run. We need to do cmd run. This one. Oh, voting is disabled, so not yet, not yet. Sorry, yeah, now. We can propose it. Yeah, propose command 1. If multiple people propose the same command, then yeah. then it will just be like very unique function on it. Basically, it's a set of commands. Okay, and now let's vote. Now just vote one. Perfect, thank you everyone. We are going to get this in, and let's observe now if anything happens in the room. Okay, did you notice that? The light is lit, like Gondor calls for aid. Perfect, so we know that the thing which is connected to this port IO extender is actually a lamp which is in the room. So let's propose another command. Let's propose the 0. Let's now set 0 to that register. So I'm going to poke 0. Basically, now we want to do this command, and let's see if it turns off. Okay, there are 2 commands proposed. Please vote on the second one. And you can vote already. You can vote now. Okay, it's going amazing. Thank you, folks. Okay, let's observe the scene. Oh no, we need to run. We need to do run. Yeah, we need to do, as Masakra says, we need to do cmd run again. So this is in 10 seconds. We'll have to input this command, and then we will have to observe the scene. It's not immediately executed, sadly. Okay, perfect. And now we have to wait for voting. Okay, now vote. Let's vote 1 and try to get it in. Okay, 36 votes, but this will be enough, 37. It's like this, every time we vote, the votes are going to be, the requirement is increased by 1. And yeah, the light turned off. Perfect. So, now, what we know is, we know that light, 1 lamp, or rather they have, I don't know, there are 3 lamps maybe here. At least 1 lamp is connected to the port IO extender. The issue is, we don't know on which pin. So now what we have to do is we have to test each pin, but to do that we can actually automatize it a little bit, but let's maybe just go like with binary search. So how do we go about binary search? Well, you know, we're like 8 bits, so we start with, for example, this pattern. And then if that fails, if nothing turns on, we go with the other pattern. So we test the first time, we test basically 111 0 0, and then we go with 0 0 1 1 1. Okay, which kind of means we have to do poke 10. Let's keep overwriting this line, and that will be 23 FF. How much is that? Anyone knows? Because we do have to write it in decimal in this basic, sadly. 240. I'm pretty sure it's 240. That being said, because I'm on a live stream, I am going to double check myself. So that's Python OXF0 240. Okay, I was right. So, okay, we got reset. We are on a cooldown, but when we are out of the cooldown, let's vote in this command, and then we'll have to vote in cmd run. Then if for whatever reason this is like we hit with this one, we can do binary search, meaning we can do then either this pattern, which is going to be this, or we can do this pattern, 0 0 here, and we'll be able to sooner or later actually tell. Cool. So proposing the command. Here, let me calculate this already, because it would, well, actually we can wait. Okay. And now, okay, please vote on 3. Okay, there we go. I like that folks are also voting on other options, because it took me quite a while to actually implement the bars, you know, moving. Cool. Oops, that was the other chat which I have opened, where I'm actually voting, because I cannot vote when I'm not logged in. And I'm not logged in here. Cool, now run. Now we need to do run. So we need to do this one. Okay, I see masakra already put in run. So let's just wait for it, and then we do run, and then we observe whether the light will turn on or whether it will not turn on. Let's see how it goes. Okay, vote 2, please. Please vote 2. Testing for excesses, I like it. You're absolutely free to security test this challenge. I tried to make it as, you know, versatile as possible. Okay, and run 1. Okay, yeah, we have the light. Light is actually lit, which is perfect. Which means we are going into this scenario. So let's start with this one, and this one will be... I'm actually going, you know what, to run Python for that. Python OXC0192, I should have known that. Which means we are going for... let's do this. We are proposing 192. Wait, no, wait, we have to reset the lamp. No, okay, we don't. We don't have to reset the lamp, because if we miss, then the lamp will just turn off. If we... okay, please vote 1. So let's observe. If it turns off, that means we missed. If it stays on, that means we are getting close to that bit. And it's 16 votes, perfect, thank you. And it's staying on. Okay, perfect. So it's staying on, which means that we are going this direction. So it's going to be either this one, or it's going to be, which is 128 by the way, and we can start with that. So let's go with 128. We didn't run. Okay, sorry, Masakra, you are correct. CMD run, please, folks. So wait, we might actually not go there. Let's see where we are going. I forget about run, because in actual... let's vote 1. In actual 8-bit computers, you could execute commands without prefixing them with a number, and then they would just immediately get executed, like run is. Run was actually in BASIC, you could actually use run in your program, which I don't think it did anything, but you could do it. Regardless, it did stay on, so okay, we are still good. Okay, what is this? Okay. Since we are still good, we are going with this command next. And I believe I can already put the command in. Okay, I've put the command in. Okay. Please vote on 2. And now I'm remembering. Now I remember about run. Okay, 13 votes. Perfect. 17, yeah, will be enough. We'll get it in, folks. Awesome. Now we need to vote in run again, but there's a small cooldown for that. By the way, if you're wondering why is there a dot blinking here, it means that the actual, let's say, like, thing connected to that console is still alive. So if anyone is able to crash the task, that dot will stop blinking. Okay, one command proposed, I see. Perfect. Okay, and now let's vote 1. If it stays on, that means it's going to be this bit, otherwise we need to go with this bit. 8 seconds more, this bit is 64. Okay, let's observe. Okay, we missed. So it's not that bit. Well, we don't really have to check the other bit, right? Because like it's the only option. It has to be this bit. But okay, let's test it. Just in case, let's test it. Because it's a CTF, things can go wrong, and we actually don't want it to go wrong, so let's test it. So the next command is going to be this one, and I believe I need to put this on, and it's going to be this one. It has to be this one because the light is off. So I propose like 2 more commands, and then if this works, we have to go to the datasheet again because we need to figure out how to leak the flag now. Please vote 1 if you could. Thank you. Okay. We might need a couple of more votes. Perfect, thank you folks. Okay, and now we need run. CMD run in a couple of seconds. I think my stream is a little bit behind. Oh no, it's actually fine. Okay, I believe I can put already CMD run. Shimex is wondering how many people will get shadow banned for typing vote 1. Hopefully we won't. Okay, hi everyone. Yes, hi everyone, Stefan. Okay, please vote 2. The line limit is 71, by the way. It was shown on some of the screens. Okay, well, we know the light will turn on now, right? Yes, okay. So, thank you for this experiment. We now know on which bit it is. It's 64, so we know that this is actually where here is where the lamp is connected. And it's like straightforward logic, is not negative logic, which means 1 is on, 0 is off. This is how programmers like it. That's good. You know, in embedded, sometimes it's the reverse, right? 0 might turn on the lamp and 1 might turn it off, but here, this is fine. Okay, so now let's leave this stream, because now we have to figure out, okay, we can control the lamp. How do we get the flag? We know that the flag is actually connected to this best device bus, right? This is the flag ROM is connected to this best device bus, and we have access to this best device router. So how do we get the flag from the best device router into our, well, can we print it? Can we maybe blink the lamp? Because the lamp is a pretty nice oracle for us right now, right? We can blink it perhaps with the flag, maybe. That's an idea. Let's try to explore that idea. So, what do we have? Let's read about the flag ROM perhaps first, because we probably should have done it earlier. So the flag ROM is on the bus. It's not on the XRAM, right? So we don't have access to it through XRAM. We have only access to it through the bus. It's read-only, obviously we cannot override the flag, and the flag ROM is a 256-byte ROM with a predefined hard-coded value of absolutely no importance. Yeah. The best device bus register number is used as a byte index into the ROM. So we put, okay, we put here, oh no, wait, the best device register number is used, oh, okay. So yeah, for example, on register number 0, there will be the 0th character of of a flag. On register 1 will be the first character of a flag, and so on and so forth. So I'm guessing this one has like 256 registers. This device is read-only and only available via the best device bus. So how do we communicate with stuff over this best device bus? Let's go here. Best device bus router. This is the module which we have access to. Sorry, from the XRAM MMIO, right? So the best device router is a simple copy byte from to device, okay, which will allow you to copy bytes between various devices connected to this bus. As we know from here, these are the devices connected to the bus, which means we can copy bytes between them. So we can copy a byte from other to the register, we can copy from the register to the IO extender, and we can copy from the FlagROM into the IO extender. This is cool. So, let's continue reading. This is the adder, this is the FlagROM. I'm sorry, I kinda skipped. Here we go. Okay. To execute a copy, like a byte copy, we have to set the source device ID. Let's look at the registers. So what registers do we have? We have the source device, we have the source register on address, these are the memory addresses. I believe these are decimal, the destination device and the destination register, and a control register. Which control registers usually have flags, like which control the device. For example, execute the command which I inputted into the device, which I configured the device to execute. Cool, so to execute a copy, we set the source device ID and source device register numbers to source device register and source register, MMI registers, and we write 1 into the control register. Okay, this is missing something. This is missing something because we do have also destination registers. When we copy it to somewhere. So, but we are smart. We can figure this out. The execution will be halted until the byte transfer is complete. Okay, this is good. That means that, so a typical model is actually that you set up a device and then you tell it go. But the device, like, you don't have to wait for the device to finish. You just continue. That being said, this device doesn't work that way. And usually there would be, like, in the control register, there would be a bit which would tell you, oh, the device has finished. But this device obviously freezes the CPU until the copy is complete, so that's good because that simplifies the code. It's not great if we would do, you know, actually have a device like this, but it's great for us. Cool. Then we have reading from control register will always yield 0. The behavior when attempting to copy from or to a non-existent device or non-existent device register is undefined. That's okay, that's cool. So, what we should do is probably... okay, what devices can we copy from and to? We looked at them already, but we have this register, so we can put a value in it, but we have the FlagROM. So what we probably want, we want the flag, right folks? And we know the flag is ASCII, and we know that, well, ASCII characters, if you actually man ASCII, let's do that, man ASCII. If you look at the characters and you scroll down to the bottom, you will notice that apart from extended ASCII, the basic vanilla ASCII characters are finishing at the number 127. 127 in binary is actually, let me write it here perhaps, is expressed like this. Yeah, which kind of means that if we would put a flag character into this, this port extender register, that means that we would leak this byte. We would leak, like, this would be the first byte of a flag, right? So these are the bytes of a flag, maybe FFF for flag. And then we would leak this character, which is cool. So let's leak 1 byte of a flag to see if it works. How do we do that? Well, we have to set up it to copy from the FlagROM. So this is the FlagROM, the first character into the port IO extender. Okay. How do we do that? So we have the flag ROM. We know the flag ROM is 88. And so let's do it like this. I'm going to denote the device number like this, and I'm going to denote the register number like this. So this is this is the first flag character in the flag ROM. Character. This is how do you even character? Okay. Sorry, I probably should take it a little bit higher. And we want to copy this into the port IO extender, which is this thing. So this thing is at, we have what? We have device number 15 and the register. So this is device and this is register. Sorry, the register is, yeah, the register is 0. So this is the IO extender. Here we go. And then what we have to do is we have to, where's the device router? We have to write 1 to control to actually execute it. Which means that if we can translate it into pokes, right? That's going to be 10 poke into 80. That's the source device. The source is 88. Source register, let's go with 20. Source register is 81 and that's 00. This is this one. Then, wow, YouTube tells me I should insert an ad now. No, I am explaining important things. Come on, YouTube. Then the destination device is 15 and the destination register is 00, right? We again copy to 00, which is cool. And then we do poke 84 and we have to write 1 here to execute it. And then we have to do run. So this is what we'll be doing now, folks, for the next 5 minutes. I might be looking at the chat a little bit as well to, you know what, I'm actually going to add another command here. Let's put it, so let's like move it by 10. We can still do it in Sublime. And let's poke to 23 as 0. So let's turn off the light first. Awesome. So, how do we go about it? Well, first of all, we open this and let's, okay, we are too late, so let's wait for the cooldown, and after the cooldown happens, let's vote. If you have any questions, I think this is a good time on the chat to ask them, because we'll be spending like 5 next minute or like 6 next minutes inputting this program, and this is just like leaking one byte of a flag, and then we'll have to figure out how to leak other bits, sorry, the first bit of the flag, and then we'll have to figure out how do we leak other bits. So, can we bit shift? That's a good question from Johnny. Well, if we look here, the devices which we have are here. We have a register, we have an adder, and we have an IO extender. We don't have a shifter. Let's hope this isn't going to... Okay, it's still 6 seconds. All good, all good. Let's do this maybe... Okay, let's input the command. Okay. Come on, is it proposed? Perfect, it's proposed. On the next phase, please folks vote, well, vote on my command. The command which I inputted is this one. I'm not sure if you actually can see it. Yeah, you can see it. Okay, all good, all good. Okay, vote 1, please. Awesome, thank you, folks. Okay. So we cannot bit shift, but we can add 2 things together. If you add 2 things together, that's actually a bit shift. So we can use the adder to bit shift. So I think that already solves one issue. We can use the adder to bit shift the other bits into it, but we'll have to implement it. Okay, then let's vote for the next line, or rather, let's. I'm going to input the next line. Okay, let's wait for it. if you have any questions, just write on the My Streams YouTube chat, then I can take a look. Is this a real room or is it a CGI? It's absolutely a real room. Vote 1, please. Yeah, this is going to take a while. So if you have any questions related to security, hacking, CTFs, or programming, do let me know. We can have a nice chat while we are solving this challenge, folks. Thank you for voting. 22 votes. We have the next line in. So we have now 16 seconds to... yeah, and this is, by the way... So don't worry, we are only going to leak 1 bit now, but we just want to verify that it works. And after that, we'll have to devise like a smarter way, because like BASIC is a programming language, right? So we have to devise a smarter way to leak it so that we won't spend the rest of the night here, and we can do it, don't worry. Okay. Do you know of any good hardware CTFs? I don't know of any. Okay, please vote 1. I don't know of any CTFs which are strictly about hardware, I think. There was at least one, but I don't remember its name. But no, Google CTF, that being said, does have a hardware category. So if you go to GitHub Google CTF, like just Google for GitHub Google CTF, there will be tasks from previous... okay, perfect, thank you folks. We had the next line in. So we open source a lot of hardware tasks. So you can play with them. There are some similar tasks to this one, by the way, but with a little bit less annoying interface, let's say. Okay, I'm going for the next line then. Line number 40, poke 8215, which is going to put the destination device into the best device bus router. Thank you. Shimex73 says that it was RHME2. Yes, that was the one I had in mind. Okay, folks, let's vote 1. Okay, 15 votes. That should be enough. Perfect. Thank you, folks. Yeah, there's also Hackesat. That's true. Hackesat is a little bit more out there. Well, you know, satellites. So... there's a lot of like cosmic technology there, I guess, as well. And I guess like Hackesat finals are going to happen this weekend or something. Okay, 5 more seconds, and let's put the next line in. That's going to be line number 50, which is going to set the destination register. So I propose it. Okay, 10 more seconds for voting. Yeah, nowadays a lot of CTFs have IoT and firmware category. That's true. That's absolutely true. Okay, I think we can vote 1 now. Christian says, I have been learning C, but it's hard to get over the basics. What's the best way to learn C? C is a hard language, so don't worry. If you're having issues, don't worry. It is a hard language. And what was the second? Are there Easter eggs? Of course there are Easter eggs. Come on, this is my challenge. If anyone figures out the command to show an Easter egg, then we're going to vote for it. It's not that... It's an Easter egg from another basic. Okay, we have one more. Anyway, so going back to C. Well, the best way to learn a programming language is to code in a programming language. And they're like, okay, I'm proposing another command. Somebody also proposing a command. That's good. Anyway, so Easter egg. No, Easter egg is not the right command. Okay, please folks vote 1. Anyway, so you can do 3 things. You can code stuff in C. You can read other programmers' code. You can look at other programmers' live streams when they are coding in C, like on YouTube, on Twitch, or on whatnot, right? There was this live coding platform some time ago. I'm not sure if it still exists. Apart from that, you can, well, read books and tutorials. Code the most. Like, the most important thing is coding, but also use the other ways. And yeah, that's all I can say. If you don't have ideas what to code, just Google for programming ideas for beginners or something like that. You will find a lot. And C is hard, don't worry about it. last one is going to be a run. So we are going to finally leak the first bit of the flag. And then we'll have to figure out like what we are doing with our life, or rather how to code this a little bit better. So, okay, please vote 1. Okay. 15 votes, 19 votes, 19 votes should be enough. I don't know what are the requirements, but thankfully they will soon be reset. Okay, and yeah, we have the light on, right? Yeah, we have the light on. It turned off the light here, it turned on the light here, it blinked, which means that the first character of the flag is, or rather, sorry, first character, right. First bit is, well, we know a 0 here because this is ASCII, we don't know this ones, and we don't know this one, so we know here it's 1. Okay, we'll have to go back here for a second. Now, we can already verify if we are on the right track here by, well, you know, as I said, we know the flag format. The flag format is a link. A link starts always with HTTP or HTTPS, right? So, let's look at the letter H. Letter H is the ASCII code of letter H is, no, I don't know it. I'm going to look it here. Look it up here. This is, which one is hexadecimal? This is decimal, so the next one is hexadecimal. Here, 68. If you're converting, by the way, to binary, it's trivial to convert from hex to binary because every hex character is just 4 digits in binary. So 6 is going to be 0110, and 8 is going to be this. This should be 68, if anyone could check. But yeah, it seems as much as, like, you know, we have really like a 50% chance that it matches, but we like didn't. We even have like 50% chance that it works, maybe even less, but it works. I think it works. So we got a 1, we were expecting a 1 because this is an H, everything is good. Now let's figure out how do we leak every bit of the flag without doing this all the time. We have to be pretty smart about it. Okay, vote 1, folks, if you are still there. Okay, 3 votes, but still a bit too. But I think Shimex is pretty close to the Easter egg. Let's wait for the voting, and then what Shimek has written, let me copy paste it from the chat. Shimex has written this. I'm not sure if this is the Easter egg, but this looks pretty close to the Easter egg. The Easter egg is pretty lame, but it is. Okay, so we are going to try it in 30 seconds, but before we go there, we have an adder, right? And I said that an adder is going to do a bit shift. An adder is actually doing a bit shift. How do we do bit shifts with adder? Well, if you have a value, for example, 12, and let's assume this is like, okay, let's go with binary, okay? Let's go with binary 12. Binary 12 is going to be like this. And which is, because we are dealing with 8-bit numbers, so this is like this. By the way, yes, let's propose Shimex or Heidel. Yeah, let's propose the commands. And Heidel or Hidel, I think you're onto the command, the correct command. Okay, vote 1, folks. This is an Easter egg from Commodore 64, which when you typed it, it showed Microsoft and an exclamation mark, and it was actually obfuscated in the code. You can read about it on Wikipedia, by the way. And what do we get? We get Ginvale. Yeah, the same Easter egg which was in Commodore 64 and was discovered pretty quickly by my community. I'm really proud of you folks, well done. So, we have the Easter egg, now we need to get the flag. Yeah. I wanted to plant in another Easter egg. When you would type command help, it would show you that the trauma team has been dispatched. If you played Cyberpunk, you kinda know. But at the end of the day, it shows the link to the PDF, which we are now going to read. Okay, so other, right? So bit shifting with other. So we have this value, which is 12, right? This is 12, a decimal. And we want to bit shift it. So bit shifting is basically if we bit shift something by 1, this is obviously the same as multiplying it by 2 to the power of 1. And this is the 1, right? So, which kind of means this is multiplying it by 2, which means it's 24. And if we look here, this is a bit shift would look like this. Like you would put a 0 here and remove a 0 here. Let's fix the spacing and we get this. And if we decode it now, let's decode it first to hexadecimal. We get a 1 on this side because, again, 4 digits in binary. By the way, bit means a binary digit, right? Binary digit, that's bit. So a binary digit's a bit. So 4 bits makes 1 nibble, because nibble is a hexadecimal digit. That's how you call them. And this is 8, which means that's 18 hexadecimal, which means it's it's 1 times 16 plus 8, which kind of means it's 24. So this is the math adds out, and another way to multiply something by 2 is to add it to itself, right? That's also multiplying by 2. You kind of learned it in school, that like if you write this, then it's actually the same as this. So this is how we are going to use the adder to basically shift stuff around. And if we get like a character of a flag, right? We have this character. So what we do is we just like put this into the adder and we add it to itself, which means what we actually get is we get it shifted by 1. So after fixing, we get this, which means that on the, I hope you can still see it, which means that on this position, this is the position which we are leaking, we suddenly have the next bit which we will leak. So this is how we go about it, which is good. How do we use the adder? Okay, let's go to the devices. Okay, this is the adder. And now we do, what do we do? We have the adder, this is the address, so it's 37, and then we have registers, 3 registers. A register, B register, and a result register. So 8-bit adder performs a simple 8-bit addition operation. Register A, index 0, and register B hold the operands, which means the values which are added. And register res, which is this one, index 2, holds the 8-bit result of the A plus B operation. So, because our program is starting to be a little bit complicated, what we should do is we should kind of emulate the behavior of the needed devices, the devices which we need. And and we should test it if it works. So what's the general idea? The general idea is like this. For every character of the flag, right, because there will be multiple characters, for every character of the flag, we put nth flag character into the adder, add A. Let's go, or just let's call it A, because like there's nothing else called A. Then put A into B. Or we can put it, no, we will already have it, so let's just put it, or do we? We should put 0 probably at the beginning to, I'm trying to be smart about it, but let's see how it goes. Put 0 into, how do we put a 0 anywhere? Oh, it's going to be already 0. Or can we, wait, we have this register, right? And this 8-bit register is also available on the bus. So if we just read from this value, from this register, we're going to get a 0. So we can read from 22, 0, and we can put it in A, in B. Then we put this into A, and then we continue like this. We copy the result into the I/O extender. The I/O extender, which is, we kinda checked it here, it was 1500. Okay, so we call it into I/O, which is 1500. This one, the B and A, B is 3701 and this is 3700. I'm just copying the values from here. So we put the result. The result at the beginning is going to be... Okay, it's good. Then the result at the beginning, I'm going to, move this a little bit here so you can actually see it. I apologize for that. And then we copy... no, then we delay. Because this is going to light the lamp, right? So let's maybe print the index at which we are now on. So we are going to print the index 0, so we have to set the index to 0 here. You know what, I'm going to skip this. Okay, we print the index. There's a print function in BASIC, so we can print stuff on the console. Then we... Okay, and then we... what do we do then? We need to put the res into A register, because we need to duplicate it now. So we put the res, copy res into A, copy A into B, and then we loop. Because we have in res, at this point already, we have in res the next bit. And we do this for, basically for index in range. Sorry, this is Python. Every pseudocode is valid Python, as you know. So we do this. We don't need 8, we need 7, only 7 bits, right? Because I said already it's ASCII, and ASCII doesn't use the top bit. So we do this. There is for loop in BASIC, obviously, yes. Why aren't we printing the flag? That's a great question. We aren't printing the flag because the flag ROM, and maybe I should say that because that's not super obvious. Because the flag ROM is on the device, on the best device bus, and we cannot read stuff from the best device bus. Well, we could copy the flag character into one of the devices which we have access to, right? From the peaks and perks, which are like these two registers. The issue is they are write-only. So we could copy the flag into the register, the flag character into register, no problem. But we couldn't read it. And because we couldn't read it, we cannot print it. And because we cannot print it, the only thing we can do is we can send it to the I/O extender and blink the lamp. That's why we are not doing it. Yeah, it's annoying, isn't it? Okay, so we do this, and then after we finish this, we basically do this for the whole flag, right? So we do for, it's a bit weird indentation, but it matters because it's a pseudocode anyway. For character, so like n is going to be character. In range, I don't know how long is the flag, so 255 perhaps. I would start with actually printing n, and let's print n twice. So we are going to print n twice, because we need to somehow differentiate it from this. And then I would actually delay here. Do you know how to delay in BASIC? Because there is no sleep. You delay in BASIC by doing a for loop. So what you do is you do actually like for I or like for X in 0 to whatever to like because we don't need a huge delay, right? We can just go with a little delay, so like 20, 50 maybe. This BASIC is pretty slow. BASICs run on interpreters, so that's fine. Next X. Yeah, this is how you do a delay. So this is what we are going to do. Now the issue is that copying stuff is going to be a little bit annoying because we will be changing the destination a lot. I'm wondering if we should make for the copying a different function. You can make sub-functions in BASIC, they are a little bit weird because you don't name them. You just like put them on like, I don't know, some lines, right? And then there's something called go sub. There's like a command called go sub, and it goes into a given line. And then from that line, the next address is actually pushed on the stack. And from that line you can do return, and it will go back to that code. So if like this is, for example, 1, 2, 3, let's say this is 10, this is 20, and this is print ASDF, and here we do just return, it would go from here to here, then it would immediately return to here and execute this. So this is how GoSub works, and I'm wondering if we should actually make a function for copying stuff, but I don't think so. We are not going to make a function. So okay, so having this, how do we implement it? First of all, I don't remember how to make for loops, but I believe there was an image here, a screenshot. Okay, it's exactly how I written. It's like this starts the block and this next X finishes the block. I'm sorry for the quality of it, but it should be enough, I hope. So we should also, by the way, record the screen, but I think we can actually go back in the live stream. Yeah, we can go back. We can go back, so we don't have to record anything. That's good. Okay. Then we go with coding. So, and then we are going to probably, before I start implementing it in, we start implementing it in the console, we'll have to emulate it. So let's go back here again, not here, here. And let's convert this into actual code, which, okay, I don't have a device. Let's mark this as a command. So for n equals 0 to 255, we don't need that many, but the flag is going to be shorter. Let's just go with this. And then at the end, we are going to need next n. Perfect. Then I said we are going to print. There are no indentations, so I'm just going to do this. We are going to do print n. And this is kind of funny, because if you read the UBasic interpreter, it's enough to do this, and this will print n twice. So we are going for that. Then we are going to put to 2200, we are going to put 0 in the B register. Sorry, the B adder, right? So to do that, we have to, thankfully 0 is a pretty popular register number, so that's not bad. Oh no, this is not 0. No, this is 0, this is okay. This is going to be a little bit more annoying. So yeah, we do pokes, folks. I apologize for that joke. We do poke 22 as the source. 81 is good. Then destination is 37. That's the device router. What I need is the other. Here we go. 3700. No. 82 is 37. This is a destination bus address, and then I do 83. What's the 1, right? 1, yeah. And then we execute it, so we do poke. I'm wondering if it would be shorter if I would put it in a function, but I don't believe so, actually. It would be kind of the same amount. It might be easier to just do it like this. Okay, then we put the flag. So poke into here. Where's the flag again? The flag, sorry, flag ROM is 88. So 88. And here into 81, what we put is we put n, because we need the nth character. And then we put it 37. We already have 37. We are absolutely going to abuse the fact that we have 37 here, but we need 0 in 83. So here we need a 0, and then we need to execute it. So this is execute. Okay. Then we have a number 4. 4. What did I call n? So I'm going to call it I this time around. Equals 0 to 7. It's going to go 0, 1, 2, 3, 4, 5, 6, or is it going to go here 1 to 10? I'm guessing it's going to print 10 as well. And in our case, we don't. Wait, in that case, in our case, it's 6, or rather 1 to 6, 1 to 7. How many bits there are? 1, 2, 3, 5, 7. Okay, 7 is cool. Otherwise, because it's inclusive, probably it's inclusive, that's what I'm guessing, we are going to test it. Because it's inclusive, it would get 8 bits, and we don't want 8 bits, we want only 7 bits. Okay, then we copy poke into the resolution. The resolution is... so we need to put in 8037, and then we need to put in 81 2, because in the other the result is in 2. Okay, so that's why I'm putting 2. The destination is poke 8215. 15, let me check the previous code which we've written. 15, that's correct. So 15 and then 0, 0. What do we have in 83? In 83 we have 0, 0. So I'm not touching that. I'm going to, yeah, it's 0, 0. We need 0, 0. That's fine. We don't, we assume it's 0, 0, but we don't touch it. And then we're going 1 to execute it. Then we need to print index, so we just do print I. And then we do a 4y, or rather, let's just do, as it says here, 4x and 0 to 50, we do just next x. Because we delay, we just delay it, we don't do anything else. Okay, and then we need to copy the result. After it, we need to copy the result, which is going to be to 8. So 37 is already here, but we need 37 here as well. So we do 37 here. The result, oh, we are already on result. This is good, this is great. And here we are in B actually, right? No. What's 83? 83 is 0. So you know what I'm going to do, like here, assume 83 0. And here assume 82 is, what's 82? 37. Assume is like from assembly syntax, by the way, but this is just a comment, obviously. So we assume 80 is 37. We assume 81 is 2, which is true. This isn't, we cannot assume it. And then 83, 83 we know it's 0. It's still 0, right? The issue is that we will change it here to 1. So you know what? I'm going to actually swap it. I'm going to do it like this. Because that way we end up with 0 in 83, which is required at the beginning of this loop. We require at the beginning of this loop for it to be 0. So if I do that, then yeah, then I need to actually do 83 and set it to, what do I need to set it to? 1. And then I need to run it, 84.1. And then I do a copy from 81 changes now. So poke 81 changes to B, that's 1. And 82 is fine. So, sorry, that's, okay, assume, wait. Assume this. This is okay. Now, 82 is assumed. We also are assuming that 82 is the same, which is correct, but the destination is going to be A. So we are changing this to, which is correct, and now we are running it. And now we are running it. Okay. And this is running it, and now we need next I to finish this loop, and then next N finishes that loop. Cool. So I think we have some basic program. Now what I'm going to do is I'm going to actually copy this, and I'm going to open a file called I don't know, go bus. Bus is usually the extension you would use for basic programs. So I'm going to delete this. Wait. Here we go. Okay. This is okay. Because I don't have comments. For whatever reason, this basic doesn't have comments. Okay, and let's go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 60, 70, 80, 90, 200, 210, 20, 30, 40, 50, 60. If folks are watching this after it's already recorded on YouTube, you know you can just skip this part. If you are here with me, I'm sorry, you have to suffer with me, apparently. Okay, here, static basic program. What we are going to do is we are actually going to load it. This is going to be this large. And now file, open, fopen, I'm confusing languages. Read binary, doesn't matter, it is fine. I know it exists, I don't care. Read program. One, the size of program, I guess. F close F. Okay, so now we can execute it, but we do not have any of the devices implemented, so this will still go south, but that's fine. Let's start with this. Let's compile it. Unknown type file. How is this type? How do I have no stdio here? Okay. Warning, every const, no consts. Okay, that's fine. Let's run it. Okay, and at least it kinda works, but yeah, it kinda works. Let's go a little bit higher. Yeah, okay, so this is the result, by the way, of this. Print n was like two numbers printed one after the other. And then we do a lot of stuff. Okay, so now let's implement the devices. We are only caring about poke, thankfully. So this is my poke. And now for my poke, we are going to still do this, but a little bit differently. I'm going to create a couple of variables, so let's call them bus src dev. Oh, sorry, that's unsigned variable type. I'm going to use variable type because why not? Okay. Are we doing something else weird with pokes, or are we only chatting with the bus router? We are only chatting with the bus router, that's okay then. So, source device, source register, destination device, destination register. And then do we need this? We need other. We need other A, other B, and other res. What else do we need? We need the I/O register, but I'm going to actually emulate it differently. So okay, let's go with this. Now I'm going to do a switch of A, which is the address, and I'm going to go with device addresses here. So if the device, you know what? Actually no, switch would be nice, but I'm going to go with a different approach. If the device is the router, that's 37. No, that's the other, right? Others. So let's start with the other. This is the other. If v is equal to 0, then we do other of a is equal to v. The code is going to be absolutely ugly, but we don't care. B. Okay, do we actually we do wait. No, wait, this is wrong, because I'm only using these ones, right? Okay, so no, this is like, yeah, I'm one layer detached in my mind right now. Which kind of simplifies this actually, which is good. So if that's the bus source def equals v, okay, then we kinda, you know the drill. copy pasting stuff, which means that I will be making copy paste errors. If a is equal to 84, this is where the fun stuff happens. I'm assuming that v is going to be 1. Okay, let's do actually v equals 1. Let's do this check. And let's do a print here, but I'm going to do I'm just going to say that like it's I'm going to print actually 4 registers here. Okay, and we do bus source bus stuff. Okay, and this is destination and destination. Let's see if this works. We can do here now. Okay, that's fine. If I recompile it, it usually runs better, right? Let me move this a little bit higher. Okay, so this works, and now we have to actually emulate the devices, right? So I'm going to do this, and now. Okay, so there are like 2 things here. There's going to be the variable type, let's call it source maybe, and set it to ff, or whatever, don't set it, then we get a compilation error if something fails. And then we do a switch. No, an if is better. If bus source device is equal to, and now let's go with other first. So other is 37, and bus source register is 0, then we do source equals other A. Okay, let me move this a little bit here so you folks can see it. Maybe like this. This isn't the greatest, but if I do this, it should be fine. Okay. Boom. Yeah, this isn't the type of... This isn't like how you should write code, right? B, and you know what? I don't care about this rest thing. I'm going to do here, so I'm just going to do other B plus other A. I probably need a little bit more space though. Okay, so this handles the other emulation. Nice emulation, right? And now let's handle the... what else are we using? We are using the register 22. 22, where are you? 22, this is 22, 8-bit register. Okay, so if it's 22.0, then it's just 0, because we are not putting anything there, so I'm just going to be lazy, and I'm going to put 0 there. Then what we do is we need the I/O register, but that's the destination. We are never using I/O. Oh, maybe we could have used I/O register as a source. Well, never mind. I didn't do that. We need the I/O register as the destination. We need the flag ROM. Okay, so I'm going to put like some flag here. Static, unsigned, or static, yeah, well, char, whatever, doesn't matter. Flag, and like real flag, totally real flag, yeah. And I'm going to put it to HTTP, yeah, totally the flag. Okay, something like this. And therefore, if this is the flag ROM, which is 88, are we using 88 here somewhere? Yeah, we are using 88. That's a good sanity check. If it's 88 and register doesn't matter, because we actually need to use this register as an index, then the source is going to be equal to flag, real flag. Real flag of this. Then we need anything else is used as source? I don't think so, right? Let's look at the console then. 37. Okay, so wait, which one's the source? Am I mixing stuff up? Oh yeah, I mixed stuff up. So this is the source. 37, 37, 37, 22, 37, 37, 22. Only these things are used as source. And 88, where's 88? 88 is here. Okay, so only these things are used as source, so I don't need to care about other things. And then we need the destination. So if the bus destination device is 37, it's the other, right? And, well, I kind of need to copy this, I guess, but it will change the order now. And I need to change this here to destination. Then yeah, then we put into other, we put source. Into other B, we put source. And nobody is writing to this register because it doesn't make sense. You don't write to the result register. I wonder if that's actually in the documentation, but that doesn't matter. Then, what are the other? That's either 37 or 15. We are not using any other registers apart from these ones. So 15. And, okay, 15 and 0. Then we do printf and something like this maybe. And then here we do whatever is in the source, but on the bit number was it 64, right? So what was the mask for 64 again? Was it 40? Yeah, it was 40. Okay. 40, and we should, you know what, I should actually just like do source. Was what, 6 bits, right? 6 bits and 1. Okay. So you can print it now. Okay, so this is, yeah, this is an emulation. And let's see. We don't have to go that far with the loop. I'm going really far here to like 200s, right? And we know that the flag is only at the beginning. So, you know what, I'm going to change this to something, okay, like small, 30, for example. So let's do clear, and let's run it. Okay, and yeah, and it changes the bits. So it seems to work actually, folks. Maybe we should start implementing it. Let's go to the first one. 1101. Is this what I said that H is? H. 1 1 0 1. And then 3 zeros. Okay, perfect. So I think it works. Which kind of means that, this was needed only for testing, right? Which kind of means that we can start going with these commands. We have 27 commands to put in, which means we'll be here for half an hour. And then we'll still have the flag to decode, though maybe I will not be decoding it fully on the stream. I will decode part of it. Okay, therefore, let's go here and let's start with the first command. Okay, cmd this. I'm actually going to copy paste everything from here to here. If you could help me vote, I would be really happy. So vote 1 now. Let's see, how many folks are there? Okay. Perfect, 11 votes. 13, good, good. If you just joined the stream, I'm going to give you a link to this live stream which we are raiding. Okay, we got the first one in, so we have this one in. Now let's do this one. If you have any questions now, this is the time for chat. We'll be here for 20 minutes. So yeah, if you have questions, do let me know. Just ping me on my my YouTube's chat, like, you know, @GenValeEN, and I will try to answer your questions. And let's propose the next command in the meantime. Do you have some efficient way to learn algorithms? The way I usually did it is I looked for an animation on like YouTube, for example. When I was learning algorithm, there was no YouTube, but now you can look for YouTube for like somebody to show you animated how the algorithm works. This helped me a lot understanding it. And then implement it. There's no way around it. You have to implement it, you have to test it, you have to figure out all the edge cases and test it against the edge cases. 20, perfect, 22. Thank you, folks. So we have the second line. Now let's go for the third one. Yeah, and that's it. Maybe after you already know some algorithms, like, you know, the basic ones, right? Go for like some, like, what's it called? Like competitive programming, like Speed Judge Online or something like that, or like, what are the, like, Top Hacker or something like that? There was something like that, I think. Okay, next command versus the third line. I have to remember about run, that is true, but that is a long way to go. Please vote one, folks. Okay, thank you, this is going nice. Okay, 19 votes, this will be enough, but we will... Oh, good, a couple of more folks. Okay, so this is the next one. Yeah, I'm going to add run maybe now at the end, because I would forget it otherwise. Is this fine? This is fine. Okay, now I'm going to propose the next one. Proposing the next line, that's line number 40. How many times someone put never-ending blinking light program? Okay, vote one, folks. That's a good question. How many times somebody put like just like constantly blinking with the light in the room? We can do that, by the way, at the end of the stream, because it's like a super short program at the end of the day. But I don't know if anyone did it apart from me while testing. Okay, 19 votes, that will be enough. Perfect, thank you. Then that was line number 40, we need this line next. Thankfully the light bulbs are pretty solid in that room, and they didn't like die from that. Like LED lighting is way better than it, you know, normal bulbs. Okay, proposing the line number 50. Will the Hacking Google Challenge sources, including the ones for this challenge, be published for, like for Accelerate and Google CTF? Maybe. This challenge will be published as open source. Not sure about other challenges, maybe. Not all of them can be published, in honesty, but like, for example, how do you publish the bonus challenge for episode 3? I don't think you can do that, but for other stuff. Okay, and we got line number 50 in. Morse code with a lamp. Yeah, this is basically what we're doing. This is actually, we are doing binary code with a lamp, but yeah, but this is really close. Like, it's a really good analogy. The issue is that we can only turn it on and off. Well, we could do like change the time, how long the lamp is on or off. That's true. The issue with Morse code is that Morse code isn't... wait with voting, by the way, until the phase changes. The issue with Morse code is that... Okay, vote now. The issue with Morse code, sorry, is that it has 4 characters, not 2. Binary code has 2 characters, 0 or 1. Morse code has 4 characters. It has like a, you know, a long and a short signal, but it also has a long and a short pause. That's why it's 4. One is used to separate signals, and the other one is used to... perfect, we got it in. Thank you, folks. The other one is to separate letters. Not letters. Yeah, letters. So yeah, so Morse code would be harder here. It would be slower as well. Binary code would be faster here, I believe. Maybe not slower, though. Okay. Proposing the command for line 70. And yeah, as Szymek says, in like regards to blinking the light, there is a timeout. After 20 seconds, I think, or 30 seconds, the application goes out. This is the time to vote, folks. Please vote. Thank you. Okay, 14, 17. Awesome, we should get it in. Let's see what are the next vote requirements, because I didn't take a look before. We got 20 votes. We will be nearing that amount. Yeah, 17 votes are required next time. So, yeah, if anyone's watching and hasn't joined our raid, then you are welcome to do it. More than welcome, actually. Why the delay again? The delay is basically so we kinda can observe the signal. Like you're asking about, I'm guessing, this delay here. Yeah, this delay here is because we need to observe the signal. Actually, you know, whether the lamp is on or off, we need to see it. Okay, I believe the time for voting is now. I know that, like, you're dealing, folks, with the lag of watching me on a stream doing the which, like, there are two streams in the way, and you're right. Perfect, 24 votes. This is great. This is absolutely amazing. Thank you, folks. Oh wait, wrong line. Or is it? No, that's the right line. Okay, 18 vote requires for the next one. We got 27. We are going to get it. If you have any questions on my YouTube chat, just like ping @GenValeEN and I will try to answer your question, because we have like 20 more minutes, basically. Okay, I'm putting in the next command. We could probably find a faster communication method in terms of blinking, but it would take way longer to implement the number mapping. That is true. Like, one thing we could do, maybe, if we would have okay, vote 1. If we would have know exactly how fast this machine operates, then we could just like use the... No, we couldn't use the character code as the length of time. We couldn't use it because we cannot get it to the basics memory, because it only is copied between the best device buses devices. So no, we couldn't do that. Okay, we got line 90 in. We got 25 votes. 19 are required next time. And we reached line number 100, which is amazing. Okay. Okay. From Neolex, a question: do you have advice on how to switch in career to basic web, junior web pentester to another field like more low level IoT or hardware? It's a good question. Like, you need the skills to be able to do it. Please vote 1, by the way. If internally at your company there's an opening like that and they take junior folks, then that should be rather easy. If that's not possible at your company, then you'd actually have to learn it on your own enough to be able to pass. Perfect, we got line number 100, 23 votes. Thank you, folks. You would have to learn it on your own to be able to pass the interview at a different company, which kind of boils down to, if you want to switch, yeah, you need to learn, and you probably need to learn fast as well. Yeah, the sooner you get to a decent level, the sooner you'll be able to switch. I don't think there's a magic way to do it. At least I don't know one, sorry. Okay, one proposed command. Yeah, how is there like 16 watching and we get 23 votes? I don't know. Vote 1, by the way. I don't know, that's a great question. I think there's something wrong with the way YouTube... I think YouTube estimates how many people are watching. YouTube doesn't really show an exact number. Okay, 22, that's barely enough, I think. Yeah, next one required is 21. That's okay, we are going to get one cooldown, but that's fine. So let's try to get one more line in, and then we can... if we get a cooldown, it goes -10. Then the next vote requirement would be 12 or something. Okay, line number 120. I'm proposing it now. Where did you install Sublime Text from? Using Flatpak or from the website? I honestly don't remember. I installed it some time ago, so I don't remember. It's a good question. I'm still kind of wrapping my head around like Flatpaks and other stuff like that. And snaps. Vote Okay, that was quite a lot of votes. 21 votes. Awesome. 26 votes. Oh, wow, 27. Folks, you're really active this round. Maybe we can get a couple of more lines before we get a cooldown. 30 votes. That's amazing. Okay, let me prepare the next line. Do not vote until the prompt for voting is on the stream. Okay, that's fair. Like the moment the commands are displayed after the command proposal, then you can vote. And there's like 30 seconds for voting. Okay, proposing line number 130. From Nick Hill. Any stream on RFID NFC security, maybe something related to relay attacks. I honestly don't know anything about radio at this moment, but when I learned that stuff enough to, you know, be okay, vote, enough to kinda be able to talk about it or play with it, then yeah, then we could do it. I would be excited to do it actually. Okay, I like Web3 hacking and progressing. Find it good, but the problem is I'm unable to learn other technologies. What to do? Well, if you're 31 votes, folks, you're amazing. Thank you. We will get a couple of more lines before we get a cooldown. Okay, I'm preparing the next one. So, if you're having issues with trying to learn something, you can either try to split that problem into smaller pieces. You can watch a person who knows how to do it. Let me copy paste the new command. A person who knows how to do it, watch how they do it, try to mimic them. For example, for coding, one thing I do is like I grab a program and I just retype the program, manually typing each letter. I retype the program. I don't copy paste it, I retype it. Please vote 1. And after I retype several programs, I kind of get a basic idea about the structure of the language. And that's how I learned programming, by the way. Perfect, 24 votes, 28 votes. Awesome. The other way, well, just you might have to hire a tutor or like go into a training. That might unblock you. 32 votes received, 24 votes. Next requirement. 150. That's the line we are going for next. Problem is some people are voting watching this stream instead of a second stream. Yeah, I know it's a little bit hard to watch 2 streams at the same time. Okay, I'm proposing the next one. What's your plan for next Wednesday stream from Nadir? So one thing which I'm going to change probably is I'm probably not going to stream regularly. Okay, let's vote 1. Like, I'm probably going to go a little bit more chaotic and just randomly... This is going good. And just randomly turn on streaming from time to time. So it might not be Wednesday, it might be Tuesday, it might be Thursday, it might be some other hour, we'll see. There will be some, like if I prepare a stream and prepare the topic, 33 votes, amazing. If I would prepare a topic, then it would be a scheduled stream, like the one today. But if it's not prepared, then yeah, it will probably be like random hour without any scheduling and so on. As for what will it be about, I still need to make I'm probably going to make a couple of streams, okay, proposing line number 160. I probably need to propose a couple of streams which are, where I will just like finish coding my infrastructure for the live stream because I am still missing a lot of stuff, which I had before, but I switched operating system, so yeah. Okay, vote 1, folks. Yeah, so probably like just coding tooling will be the next topic. But after I get that done, I do plan to go for some probably Stellardrone, like digging through Stellardrone because Stellardrone was pretty awesome and I would like to make a stream about it. 35 votes, perfect, thank you folks. Okay, 170. Do all numbers have to end in 10? No, this is actually a trick, as in like if we would miss a line, then we have like 10 more, like a space of 10 basically, where we could put that line in. For example, let's assume I miss here something, I forgot to put something here, right? So I do 155 and then I could put like the missing command here. this is why we are doing 10, just for safety reason. This is like an old habit. Sometimes folks did 10, sometimes folks did 5, but basically this is how you coded back in the olden days when you were coding with a line editor. Okay, that's quite a lot of votes. Will we get it before the cooldown? 170, 24 votes, that might not be enough. 24 votes, okay, we get a cooldown. Too few votes. Next one is 16, so we will be able to go like 10 more lines, and we are almost near the end. So all good. Stefan says, Flipper Zero has a bunch of cool radios like NFC, RFID, and so on. Yeah, but my issue is that I really don't know too much about radio, so I don't want to buy Flipper Zero yet. I have some, like I have HackerF, and I have a couple of other tools, but yeah, I still need to I need to repeat this line by the way. I still need to learn a little bit more about radio. Okay, let's go for this line in 16 seconds. If anyone just joined, then remember we are riding this stream. I'm going to give you a link on YouTube chat, on my YouTube chat. This is the stream which we are riding and where we should do the voting. Okay, voting disabled, come on, come on. Okay, proposing command line 170 again. Let's get it in this time, folks. From Vyets, is there any chance of a ponying conference to get resurrected? No, I doubt it. I doubt it. Yeah, it was a great conference. It was great while it lasted, but yeah, there might be different things in the future, though. Okay, vote one now. We need 16 votes. Required 16 votes, as you can see at the bottom here. We should easily get it. Okay, we got 28 votes. Yeah, we easily got it. Thank you. 180 is going to be the next one. Then let me prepare that. Okay, 31 votes. Cool. That one is in. Yeah. Remember to vote on not on my live stream, but on the live stream which we are raiding. The one which I gave on the YouTube chat a link to. Okay, and I'm proposing line number 180. Cool, 190 is the next one, but let's just vote on this one first. Vote one now. Okay, let's go. We need 70 votes. Awesome. Absolutely amazing, folks. Yeah, we easily met the criteria. Almost double it, I think. Next one is 190 then. Yeah, 35 votes, we doubled the criteria. Perfect. We will be able... With this activity, we should be able to like not hit another cooldown until we finish the task. Neolex, what were you doing technically at your job? I think you're not into binary exploitation, but more reversing. Do you have examples on what were you doing? I was doing, and I'm still doing a lot of different things. Like, literally, I like sometimes do a lot of programming, and sometimes I forget to submit a command, like now. Maybe it will still squeeze in. Yes, it's good. It's very perfect. So, vote one, vote one. Anyway, so yeah, sometimes I do programming, sometimes I do web security, sometimes I do like pen testing, sometimes I do malware analysis, sometimes I do low-level exploitation as well, sometimes I do like firmware security, sometimes I do graphic design because there isn't anyone better, and yeah, and sometimes I do maps for games, and sometimes I do some other stuff, like, yeah, like trainings. Perfect, we got 190 in, 31 votes. Absolutely amazing. Now let's go with line 200. We are pretty close, folks. Proposing line 200. What are the great things on my ears? These are the bone conductive headphones. These are like headphones, but they don't have speakers instead. Okay, let's vote one. Instead, they like just vibrate. And they're pretty good because they are, like, the voice quality isn't great, okay? but they don't cover the ear, so it's not too hot. And I can hear the environment, that's why I like them. They are great for audiobooks when walking. You know, to hear the traffic and so on. Okay, that would be line 200, and easily we got it. 34 votes. We will be able to get the run command in as well. Obviously this is incorrect, I do need to fix it before I run it. I prepared line number 210, which is like 210 in human. Okay, proposing it. Will there be a chance to meet you in the future in a, for example, Wrocław, maybe a conference? Yeah, I'm from time to time I'm in Wrocław. I have some friends and family there, so if there are any events happening at the time in Wrocław, I usually would go. Vote 1, please, folks. Okay, we are going to get it, I think. Yeah, easily. Which one is next? 220. Here we go. 33 votes, nice. And we got next requirement 21, that's okay. 16 seconds to copy paste the next one, that's 220, that's okay, yeah. Okay. Wasn't it CMD run? Yeah, it was CMD run. I just fixed it. Okay, proposing next command. Line 220. I'm looking at the chat. Yeah, we have still like 10 more minutes. If you have any questions, then on my chat, just like @ginvale_en and ask the question. If you have any questions related to security, hacking, programming, or anything else which I might actually be able to answer, then feel free to ask. And feel free to vote now. Did I vote? I did not vote. 32 votes. Okay, did you get it? Easily. Great. Now let's go with the next one. Okay, in 15 seconds. It reminds me, Yusagi Ojimba says, it reminds me of program loading from tape. Yeah, program loading from tape was the worst thing ever. It took like, I don't know, like depending on the computer, right? And the technology used, but it took from like 3 minutes to let's say 15 minutes because it was so slow. And I think it was like 5 kilobits per second or something like that on Atari X100 XL by default. We go with vote 1, folks. Not yet, it's not yet time for run. This would probably not work too well. Anyway, so yeah, and if something failed in loading, then you'd have to, you know, restart and load again for 15 minutes. I don't know, you touched the table with your leg or something and there was a vibration and the head jumped. And yeah, that happened, and then you'd have to wait like 10 more minutes to reload the game. That's absolutely like this. It's kind of like, almost like communicating with Mars as well. That would be a longer delay though. Okay, proposing the next command, line 240, we just have 4 more lines left and then run. How to start embedded systems from Nadir. I would say just like get Arduino or get Raspberry Pi or something like that and play with it, like buy some parts if you can. Or get an emulator and play with it. There are emulators as well. Do vote 1, folks, now. Yeah. And there are emulators, so you can like play on emulators as well. You don't have to buy the actual equipment and then try to code there. That's the cheapest way to start, is with an emulator, I guess. And that was line 240. We got it in. 34 votes in. Perfect, folks. And then we have 24 votes required. So we should be able with this voting get, without any other cooldown, hit the rest of the program. Being into security is hard to understand gray. How do you manage your grays? I'm guessing you are, wait, what? I need to propose the command. Here we go. Line 250. I'm I'm not sure it's that hard, but it is a little bit tricky at times. I've recently wrote a chapter on segmentation fault. Perfect. Vote 2, folks. Vote 2. Please don't scare me. So it's like this. I recently wrote a chapter on hacker ethics, or rather ethics in hacking and how to navigate it. And yeah, there are tricky places as well. And especially when you just begin. Perfect, we got 250 in. Thank you, folks. We got 250 in, which means, well, 260 is next. So there are tricky areas to navigate, but at the beginning you have to kind of learn about hacker ethics, and then it should be fine navigating it. There are some weird stuff, and yeah, sometimes you just have to try and like see how you feel, or like chat with senior folks and chat with them about like what are the consequences of certain actions which you might take, because they probably know, they probably thought about it, they can tell you about it. So yeah, I'm like, you know, years. Okay, vote 1 now. I'm years in security, so like I'm like 15 years professionally, and I was like as a hobbyist a couple of more years apart from that. So yeah, I had time to get my grace in order, I would say. Okay, that was 260, we will get it in, perfect. It's going to get tight with run, but we should be able to get it as well. I'm going to copy 270. Okay, there's from Rodrigo. Again, there's a set of weird questions. In your opinion, let me just not miss the counter. Okay, here we go. In your opinion, what do you find more interesting and why between red teaming and general blue teaming? SOC, incident response, forensics, etc. So in general, security is fascinating, but I have an offensive heart, as in like I do prefer red teaming. Usually I do prefer it in like vulnerability research stuff. That being said, I did some malware analysis and some other stuff. It is cool. I did some forensics trainings as well, like not have like doing them for people, but rather being trained by somebody. And 34 votes, 37 votes. We are so close, folks. I see you're excited as I am. Yeah, so for me is red team. But like, yeah, all kinds of security are pretty amazing and pretty, like, there's like, you can go in depth in any area of security, whatever, like, is it SOC or is it like forensics or is it whatnot? There will be stuff to just go deep and deep and deep and fell into rabbit holes, and this is what I most enjoy about security and about like IT in general. Name of your book. My book is not yet in English, so the one which I told you about, the chapter which I've written there, I just written one chapter there. It's going to be like RAM run. Okay, 2, vote 2. RAM is cool, but let's go for 2. So it's going to be like basics of security or something like that, or introduction to security, but it's going to be in, oh, is RAN actually going to win, or is RAM going to win? Hopefully. Okay, now folks, this is running, so observe it. We can scroll it back, but let's observe it. Note that this is pretty slow, and actually there is a timeout, but that's fine. We are not going to leak the whole flag with the delay. Yeah, 20-second delay. That's okay. That's okay. What we could do next is we can decrease the delay. And what we could do more is we could change the here from like, we don't start with 0 again. We start with, I don't know, like 5 or whatever was leaked. 3 was leaked. So instead, let's just go to, scroll this back a little bit. I'm going to stop it, and let's decode the characters which we have. And yeah, we kind of know the drill now, right? So we don't have to do it again. Let's go. Okay. Wait. Just like scrolling, this is a little bit hard. So let's go back. Okay, here we have. Let's start it. Is there like a, can I go frame by frame? But it's like shift, like question mark. If you press, you get this. Next frame, yeah. There's the frame by frame is like dot. So dot. This is like, okay, let's go back frame by frame. Okay, this is 0, 0, and this is 1. 1 is on, so let me mark it. Let's write it here. This is 0, and we have 1 is on, which means we have 7 positions, right, for every time. And here we have a 1. It is on. It is wait. This is probably not. I have this font, which is usually looks pretty cool, but it's not helping now. A B C D E F G H D E F G. Okay, here we go. Now is 1 here. Let's continue until 2 shows up, and a little bit further. That's a 1. Can I actually do this? Okay, this is, wait. Let's do maybe it a little bit smaller. Okay. And this one a little bit like this. Here we go. Cool. Now, this. Let's click here. Next one. 3, 0. 4, 1. So 0, 1. 5. I'm just tapping a dot. That's a 0. 6, 0. 7, 0. So that's 0, 0, 0. What were we expecting? Or rather, instead of what were we expecting, how about we run Python and check it? So that would be Python. And we have a character, which is in binary, that's OB, 11010000. And that's an H. Perfect. So we leaked H. We know that the first character of a flag is H. Let's go for the second character of a flag then. Then we just... Okay, 1, it's 1, 1, 1, 0, 1. So 1, 1, 1, 0, 1. 4, 5. Okay, so... wait, I lost count. This is 1, 5, I have 5. Next one, 6 is 0, and 7. 7 is 0 as well. So we have 0, 0. What is the next character of the flag? We know it's a link. It should be HTTP, right? So if we do go here, we do CHROB and this. Is it T? It is T. Perfect. So we are successfully leaking the flag, folks. Now it might go a little bit, longer until we leak all the flag. The flag is somewhat long. Let me leak another character. It's 1. 2 is still light on, but also a 1. 3 light is on 1, 1, 1. Then 0, 1, 0, and 0 we know, but it's a T as well. So we have a T, and then it would be a link, right? So it would be P, and we don't know the next one. Is it S or is it not S? I think it's an S. Anyway, so what we could do now is we could continue this. We would have to, again, change this line. Somewhere here. And continue with this, but I'm actually going to maybe not leave this as an exercise, but not show you the flag. I apologize. But it would take us half an hour to finish this task. And I think it's pointless because we kind of know how to solve it now. Now, if you'd like to solve it on your own, this task will be open source, but that's still not a very good way to solve it. Instead, it will be in a couple of weeks, probably in 2 weeks, we will switch it into a website mode, basically. So, so there will be a single player version of this task where you will be able to just interact with the consoles here. Like, you will be able to type on it, and you'll be able to input the program, no issues. And there will be a new flag as well. So basically, I would, if anyone survived the stream, I would invite you to basically try to solve this on your own. Try to decode it. Especially if you're a beginner, you know the program already, right? Which you have to run. So try to decode the binary then. That might be a cool exercise. If you're not a beginner, I'm actually going to think about maybe adding some more Easter egg to this. So there should be something for you to do as well. So that's it, folks, I guess. Now, I believe we have this task. So what we can do now is also maybe put up a sign for epileptics. That's true. If it would be blinking harder, like, you know, like it would be a totally dark room and it would be like suddenly a hard light on the room and then black and hard light, then yeah, I would put a sign. For this, I think it's still acceptable. Cool. Okay, but some folks are disappointed that Pokemon wasn't the Easter egg. Okay, that's a fair one. That's a fair one, actually. I agree. If there are any questions, if anyone has any questions related to the stream, to what we did, to any part of the challenge which we solved, do let me know. And I will still stay on the live stream and on the chat for, let's say, 5 more minutes, and I can answer your questions. Otherwise, feel free to, for example, join the Discord of the CTF. If anyone would want to finish the task today, just join either our Discord or the Discord of the CTF. If you go to Hacking Google, this is the address of Hacking Google. I'm going to give you a link to it. Yeah, if you go here, there is somewhere here a link to a Discord of the CTF. I don't know where, actually, maybe in info. Info, readme, or frequently asked questions, maybe. Okay, I need help. Yeah, if you go to I need help, there's a link to the Google CTF Discord server, and maybe you can find some people there to help you finish with the task. I might actually change the voting requirements to be a little bit better, to be like 5 or something instead of 10, but I'll see if I can do that, but I have no promises. And yeah, okay, so are there any questions? Are there, there's a good question from Streetpanko I86. Are there any other I/O connected to the room to poke? No, this is the only one which is connected, which is controlling these 3 lights here. What are the weird headphones? These are Aftershocks, which are bone conductive headphones, which are cool because they don't cover the ear, so I can hear the environment, which are pretty good for walking around and listening to audiobooks. In info, there's Discord HTML. There's also a Discord HTML in info, which I missed. Okay, Shimek says, did I really? I might have missed. So let's click info. Oh, it's a double click. Oh, Discord, yeah, obviously. Okay, yeah, thank you. Thank you, Shimex. Yeah, I didn't know where it is, so yeah, now I know. Okay, there's a question when you're starting in your field. What were the field top dogs you were following? When I started in security, that was El Kantów, which is Michał Zalewski, and Joanna Rutkowska, and also Nergal, which is... these are all Polish researchers, and I have like my deepest respect to them, and I was always looking up to them. Like, yeah, you can, like, for example, read El Kantów's book, Silence on the Wire, from Michał Zalewski, from No Starch Press. I always found it, like, absolutely amazing. It's, like, it's a book about security, but it's more about, what I found cool in it is it was, like, kind of a gateway to see how Michał thought about things, how El Kantów thinks about things, in, you know, research-wise. And that was like, you know, like all these out of the box ideas and so on. It was like great to see like a researcher looking at stuff and describing how he looks at it. Absolutely amazing. I loved it. It's also a bit old book, but I still would recommend it. Discord server invite is invalid for me. Okay, let me try to do something about that. I just got pinged. Okay. How do I... Oh, I know. I will post a link to the Discord, to the Google CTF Discord in the YouTube chat in a second. As soon as I figure out how to make a link. Copy. Here we go. Okay, and there is a channel dedicated to this challenge, so if you want to try it still with a group of friends, then go to that channel and synchronize there. If you want to go to my Discord though, that's just like Gunvale Caldwin PL/Discord. Are there any other questions? Have you seen this 8-bit on a breadboard playlist? Is it from Beniter? If so, yes. It's absolutely amazing. And yeah, such projects are cool. I need to make one, but I just need to find time for it. Okay. Are there any non-IT hobbies you discovered recently? Good question. Recently, no, I wouldn't think so. I want to learn to play on a guitar, on an electric guitar. But that's something I want to start actually soon, but that's about it. It's not a hobby yet, it's something I want to do and I want to try, but we'll see. Cool. Okay. Oh yeah, Shimek says that yeah, one can solve it with his emulator. Yeah, Shimek also emulated the devices when he was writing the program for it, but I think he's done a better job than I did on this live stream. Like, I've done really hacky code, but he did a little bit better. Blame Drop is asking, what's up with Raspberry Pi availability? I would like to know that as well. I thankfully had some... I bought Raspberry Pi 4 when it came out, like a couple of them, and I'm happy with myself that I did that, because currently trying to buy Raspberry Pi is weird, but it's probably due to chip shortage or whatever. There is this site like RPi Locator, I believe, where it tries to show you where there are stores which try to supply it. But yeah, it's kind of weird. CTF code quality is best code quality. Absolutely agreed. Yeah, I'm not sure other people do, but I do. Ian says that it might be because Raspberry Pi is prioritizing commercial customers over hobbyists. Who is using commercially Raspberry Pis? That's interesting. That's an interesting question. Okay, I think, folks, we can finish the stream at this point then. Thank you very much for playing. I invite you to try hacking Google. The challenges are still up. I think this challenge, well, my challenge will be open source, so you can later take a look how the actual YouTube bot was coded, how was the composer coded, which, you know, which rendered the scene, because this is actually a composer coded in C, it's not OBS. You can see how the consoles were coded, how the BASIC was actually running in an 8051 emulator. You can explore this if you like. I had a lot of fun coding this, actually. So that's it. Thank you to everyone. Thank you to my moderators. That would be Masakra and Foxtrot Charlie for being here. Thank you to Hlinur for being here as well and moderating the other chat. Yeah, thank you to the whole Hacking Google team for making the docu-series, the events, the challenges. Was absolutely amazing, and I loved being a part of it. And thank you for everyone coming here and helping me vote raiding the other stream and voting in our program. So that's it, and see you in next week, I think. And yeah, because I still don't have all my streams set up, there is no ending music, and my stream is just going to suddenly stop. So that's it. Take care, folks. Best of luck, and keep hacking.